Next, we're going to review antiderivative. Notice that it's a reverse process of differentiating. So you just need to think backward. Okay. So the corresponding section for this antiderivative is 4.9. So you probably want to read over the textbook 4.9 for more detail. Okay. First, we're going to start with a power function. So for n not equal to -1. Okay. So excluding 1 over x. So what's the most general antiderivative of this function on an interval? Okay. Well, remember when you differentiate, the power is going to decrease by 1, right? So when we take antiderivative, the exponent is going to go up by 1. Okay. So reverse it. So it go up by 1. So we'll have x to the n plus 1 power, from n to x to the n plus 1. Now, however, when you differentiate x to the n plus 1, you will have this n plus 1 in front. This one doesn't have n plus 1 in front. So to cancel with this, we need to divide by n plus 1. So the most general antiderivative of x to the n is going to be x to the n plus 1 divided by n plus 1. And then don't forget, you put plus a constant at the end. Okay. So, okay, let me make a note to this. So exponent over here is going to increase by 1. And then over here is divided by n plus 1, divided by the exponent. Okay. Now what about e to the x? Well, e to the x when you differentiate is always e to the x. So when you reverse it, when you take antiderivative, again, it is going to be e to the x and then plus c, because that's the most general antiderivative. Okay, a to the x. A to the x, when you differentiate, you get a to the x times Ln of a. So to reverse the multiplication of Ln of a, so we need to divide by Ln of a. So divide it. So a to the x divided by Ln of a plus a constant. Now, this case, when the n here equal to -1, that's equal to 1 over x. The most general antiderivative 1 over x is Ln of absolute value of x. Because this function, the domain for this function are two disjoint intervals, which is 0 to infinity, union -infinity to 0. Okay, you can have two different constants on each interval. Okay. Now, cosine of x. What function when you differentiate give you cosine x? So that will be sine of x. Now, what about sine of x? Well, remember, sine and cosine, they alternate when you differentiate. So certainly involve cosine x, but the derivative cosine will be negative sine x. So to cancel with the negative sign, so you need to have another negative sign in front. Okay, so the derivative of negative cosine x will give you sine of x. Okay? Now, of course, all of this need to press the constant c. So just put the plus c here for all of them. Okay. Now, what about secant square x? So what function, when you differentiate, will give you secant square of x? Now, remember the SST. So the derivative of tangent will be secant square. So antiderivative of secant square will be tangent. So that will be tangent of x. Okay. Now, what about cosecant square? Now, if you remember this one above, then you can remember this, except you just need to put a minus sign, the opposite side in front. Okay. So that will be opposite of cotangent x. So this is a cofunction that, and so this one is a cofunction that, but you need to put the opposite side in front. Okay. Now, secant x, tangent x. Now we remember so what function when you differentiate give you secant x times tangent of x? That will be secant. Okay, secant of x. Okay, so that will be secant of x. Okay, the derivative of secant x is secant x times tangent of x. So what about this? What function when you differentiate give you this? Well, first I remember there must be a opposite side, a negative side here in front, because this one here. So that will be opposite of cosecant of x. So think about the co-function of this one, cosecant x, but with the opposite side here in front. Okay. Now, so what function will differentiate give you this? That will be inverse sine of x. Now, what about the last one? That will be inverse tangent of x. So I have done this quick review for you, and if you need more detail, you probably want to read over the corresponding section of this book, okay?